Hello, welcome again. We are covering the subject compressible fluid flow for civil services means IFS and Gate Aerospace exam. The next topic in the oblique shock wave is reflected wave or regular reflection from a solid boundary. So far we have studied only one wave, that is your oblique shock wave. Now if there is some wall here, okay, then this shock wave gets reflected, and that shock wave is called reflected shock wave. Okay, suppose we have a flow having Mach number m1, so that an oblique shock wave bulbs at an angle beta 1, and the flow is diverted by an angle theta. Okay, so if here the Mach number is m1, and then due to this oblique shock, the Mach number will change and it will become m2. So now this shock wave will strike the wall at point B and get reflected. The reflection of this shock wave will be such that the Mach number after the shock, after the reflected shock becomes m3, and the flow becomes parallel to the wall. Okay, so in this case, if the direction of the flow is in this direction, then the flow will get deflected here like this and become deflected by an angle theta, same angle in this case, because this is your straight wall, and the flow will get deflected by an angle theta and become parallel to the wall, because these two walls are, we have assumed that these are parallel. So if this angle is theta, then this deflection angle would also be theta if these walls are parallel. Okay. So first there will be an oblique shock which will deflect the wave by an angle theta, and then there will be a reflected shock due to this oblique shock wave, which will again bring the flow back to back parallel to this wall and reduce the Mach number to m3. Okay, and in this case this will be the reflected shock wave angle, and in the first case this is the incident shock wave angle. Okay, so this is all about, and I am reading this out. First point, consider an oblique shock wave incident on a solid wall as shown in figure, and this shock wave gets reflected in such a way that the flow after reflected wave remains parallel to the solid wall. So this flow gets deflected in such a way that the flow remains parallel to the wall. In figure, the flow is in the region 1 with Mach number m1 is deflected through an angle theta at point A. This creates an oblique shock wave that impinges on the upper wall at point B. So this is the figure, and this is the oblique shock wave, and this is region 1, and in this region the Mach number is m1, and this uh, flow gets deflected by an angle theta by the oblique shock wave, and okay, and this shock wave strikes the wall at point B. Next point, in region 2, behind the incident shock, streamlines are inclined at an angle theta to the upper wall. All flow conditions in the region 2 are uniquely defined by m1 and theta through oblique shock relation. So here this is region 2, and the flow get depicted by an angle theta, and to find out m2 we will take this m1 and this theta and use oblique shock relation. Okay, and to find out beta 1 alpha. Okay, so here we will apply the oblique shock relation to find out the conditions: pressure, temperature, density, okay, all these conditions, and Mach number in this region. Next point, at point B, in order for the flow to remain tangent to the upper wall, the streamlines in the region 2 must be deflected downward by an angle theta. So if we take now this point, so here the flow has to remain parallel to the wall. So and now in this region it is at an angle theta to the upper wall, so it must be deflected downward to remain parallel to the wall. So again the shock will take place, and this will be the reflected shock angle, and this will be your deflection angle. At point B, in order for the flow to remain tangent to the upper wall, the streamlines in the region 2 must be reflected downward through and to the angle theta. This can be done by a second shock wave originating at B with sufficient strength to turn the flow at an angle theta with an upstream Mach number M2. So here we will find out this Mach number M3 by applying the condition M2 deflection angle theta to get M3 and all other conditions and in this region 3. With an upstream Mach number M2. This second shock is called reflected shock. Its strength is uniquely defined by M2 and theta, yielding the consequent properties in region 3. Because M2 is less than, here two shocks has taken place, one here and one here, and angle of deflection is same for both, for this also and for this also, but M2 is less than M1, so this shock is weaker as compared to this. Because M2 is less than M1, reflected shock wave is weaker than the incident shock and makes an angle pi with the upper wall, which is not equal to beta. So it will make an angle pi which is not equal to beta 1 or beta 2. Okay. So this is all about reflected shock waves, and we will solve one numerical based on this, and some fundas or some points has been asked in gate aerospace from this part also. So that's why we are covering this reflected shock also.